Okay, welcome back to another episode on Mark Spitznagel's book Safe Haven. Today we're just going to go over the mistakes that I made in episode 12. I noticed that the first video in this series was published on December 4th, 2021. So it's officially been longer than a year since I started this book, and I haven't even made it halfway through. So we'll get there eventually, but I'll try and speed it up. After that, I want to thank Mr. Andrew Grant once again for his very clear comment. He spent a lot of time both explaining where my mistake was and then also providing new code for me to use that was a lot better than what I had before, in terms of how fast it ran, as well as how simple it was and how easy it was to understand. So thank you, Andrew, once again. I didn't copy it and use it in my code, as you'll see, because I didn't want to do so blindly. I wanted to try and recreate it so I could understand it as I was going through it and not just pretending to understand it by using the words that you used. So thank you once again, Andrew, and for everyone else. I'm putting these videos out there so that people can correct me, and hopefully those corrections will help you as well along with these videos. So thanks very much for commenting. Now, to go back to the video, I noticed that, well, not me, Andrew noticed a couple of mistakes that I was making in my code. One of the mistakes that I was making was I was confusing two things: the geometric average of the ending wealth paths, and then the geometric average of the dice face outcomes. So I thought that those would be the same, and I thought incorrectly. And that's why I was surprised to see that the geometric average that I was calculating earlier was not resulting in the geometric average that Mark Spitznagel was mentioning. So I fixed that with this new code by calculating the geometric average of the dice faces. That is what Mark Spitznagel was calculating, and he was not calculating the geometric average of the ending wealth of the 10,000 pathways that his Monte Carlo program was generating. So if we do that right over here, if we run this new program, just for game one, you will see that if you calculate the geometric average of the dice faces now, or the outcomes that would come from rolling a dice with the rules of the first game, you get the geometric average that he mentions in the book, which is negative 1.5, I think. I don't have the book open, but this looks correct. So that was my first issue. I was confusing the geometric average of the dice face outcomes with the geometric average of the wealth outcomes. The dice face outcomes is more like a tool, the factors that you use to multiply your wealth after every roll, and then the geometric average of the ending wealth is more of the end result or product that you look at to see what you have in the end. So I fixed this by calculating those two values separately. That was the mistake that I made in game one and in game two, and I think in game three as well. And so that's why I was so surprised to see that it wasn't working properly. It was because I was confusing those two geometric averages. But that wasn't the only mistake that I was making, or that wasn't the only improvement that could be made. Andrew pointed out that I could also make my code work a lot more simply by calculating the end result of the dice face rolls instead of making the code do so itself. So if you remember from before, the code for game 2, we had this thing where we would take the wager and we would split it up into 4/10 of it and 6/10 of it, and then bring it back together afterwards. Andrew pointed out that that isn't necessary. All you actually have to do is calculate that beforehand and then put that down as the dice faces. So just to go over a quick example so it is completely clear, these are the 6 possible factors that come from rolling your dice, because there are 6 possible faces and 6 possible ways that your wealth can change after each dice roll. So this is game 2 we're talking about. And if you were to roll a 1, the way that I end up with the 0.8 is that you take a 1 and then that turns into 0.4 and then 0.6 if you were separating this. So you'd have 40 cents and then 60 cents. And then since we're in game 2, you are multiplying this 0.4 by 0.5. You're cutting your 40 cents in half. And then the 0.6, once again, it's just staying there since this is the big chunk of gold strategy. So you're just saving that big chunk. And that leads to 0.2 as your sum there, and then 0.6. And then you add those two numbers together, and you get 0.8. So in essence, whenever you roll a 1 in game 2, whatever your wealth is you can calculate what your wealth will be after rolling a 1 in game 2 by simply multiplying it by 0.8. You don't have to go through this complicated process of splitting up your wealth into 2 parts and then so on and so forth. You can just multiply it by 0.8. And so that's what I did with the other sides of the dice. The same goes for 1.2. Let's say your wealth is now 10. If you were to roll a 6, then the way we would have calculated that before is we'd of course split our wealth of 10 into 4 and 6 for 40 and 60%. And then we multiply the 40% by 1.5 because we would be adding 50% to that 40%. And that leads us to get $6. And then there's still the $6 remaining. And you add that together and you get 12. So in essence, instead of doing all of this complex math here, all we could have done is just multiplied 10 by 1.2 to get 12. So that's what these numbers are. They are the factors which you would use to multiply your wager depending on which dice face you were to get in game 2. I do the exact same thing with game 3 here. Yep. So let's do 1.5. So let's do side 6 just as an example. Let's say we had a wealth of 1. Once again, you're splitting that up into 91% and 9%, which in this case is 91 cents and 9 cents. Since it is a 6, you are multiplying, or you're adding 50% to the 91, which is in effect to multiply it by 1.5, and then nothing happens. And this is the insurance premium, so it's not that nothing happens, it's that you lose that. And so then you end up with 1.5 at the end. And so if you take your beginning dollar and you multiply it by 1.5, you'll end up with your end wealth of $1.50. So that's how I calculated all of these values here. Calculating all of these values means that we can use the same programming we used in the first dice game for the second and the third dice games. This lets us save more computational space and it makes things quicker. I took Andrew's suggestion and renamed pathways end wealths because we're actually looking at the end wealths of all of the outcomes of our of our 300 rolls. Yeah. Something like that. Anyway, so if I wanted to see dice game 1, what would happen? I would just run this, and then you get to see, the geometric average of the dice faces is 0.985, roughly speaking. And then you can see what your 5th percentile wealth is, as well as what you expect to happen to a dollar if you roll it 300 times playing this game. So if you want to change this to the second dice game, all you have to do is change a couple of variables here, or numbers here, so that you're correctly calculating the right one. And then you rerun the program, and then that was very quick. And you can see here that your geometric average says that your wealth will grow by 0.6% with every roll. So if you have $1 at the beginning, you're probably going to get around $7 at the end. And a very unfortunate outcome would be that you would get 25 cents at the end, which is not as bad as 0.01 cent. All right, and so that is game 2. And then game 3 is the insurance payout one. So you just change these numbers once again. And I'm sure there's a better way of doing this. I just haven't been practicing my Python as much as I should be. You can see once again that your rate of growth is 3.7, which is quite high. I think the book had something lower. Let's change this. Oops. Yep. So if you... Okay. Anyway, if you start out with a beginning wealth of $1, then you're probably going to end up with around $55,000 in wealth. What the geometric average of all of these faces is 1.037, which is to say that every time you roll that dice, you can expect your wealth to grow by around 3.7% with every roll. So that's what you're calculating here. Sweet. Alrighty, well that fixes that. A big thank you once again goes to Mr. Andrew Grant for commenting here. I really appreciate it. And if you see any other mistakes in my comments, everyone, including Andrew, please feel free to let me know. I really appreciate it, and it goes a long way. So thanks once again for watching.